Good day and welcome to this class in which we will discuss construction and operation of landfills. So in the last few lectures we covered monitoring of landfills and then we covered costing of landfills. All right? And costing of landfills we were able to work out some geotechnical costs per square meter and also per ton of the waste. Right? So today this is a kind of a wrap up that we have now learned most of the things regarding the geotechnical design, and we would like to see how the steps of construction and operation of a landfill are executed and what are the stages in which you have to be a little careful of doing this design. So let's begin by taking a site and see how we will proceed on that site. So let us say that this is a site which has been selected and this area is available for landfilling. Okay. We'll be doing a lecture immediately after this on how to select a site, but let us say this is the site which has been selected and is available to us. This is the shape, this is the land. So the question is, my first steps are, let me decide the plan and section of the landfill. Now the plan is quite clearly governed by the outline of the available land. If the land is in a square shape, your landfill will be square. If the land is in a circular shape in plan, your landfill is likely to be having a circular plan. So the plan depends on the outline of the available land. And what does the cross section depend on? The cross section depends on how high we can go and how deep we can go. And how deep we can go depends on groundwater table level and or hard rock. So we normally don't excavate in hard rock. And if there is no groundwater table and if there is no hard rock, typically we do excavation up to 7 meters, 8 meters, after which it becomes problematic to do open excavations. So the section will depend on the maximum height to which you can go. The maximum height we would like to go to is a height which does not create a very huge visual impact. And I have said this earlier that 15 meters is a good height which we typically adopt. So we will know the height of the landfill. Depending on the depth to bedrock and depth to groundwater table, we will have an idea of the depth of the landfill. However, what the section will look like will also depend on the topography. Is it flat ground? Is it sloping ground? Is it low-lying area? Is it a valley? So that will determine the section of the landfill. Within the planned outline, what will influence your layout of the elements inside the plan? Where is the gate? Where are the roads? Where is the leachate pipe? Where is the treatment facility? So you will need to know where is the nearest road? How does the surface water move on the site? What is the wind direction? And what is the groundwater flow direction? So typically, if you have a site, surface water movement direction is most important because water flows from a higher elevation to a lower elevation, and if you don't want to start pumping, then if you want to make use of gravity flow, then you would always be having things flowing from a higher point to a lower point. So if this is the information which becomes available after site characterization or after site investigations, say this is the land we got and we did our site characterization. Approach road is from this side. Let us say a state highway or a big road is somewhere here. The site is having surface water flow like this. It goes from here and gets off here, right? So that tells you that this is higher elevation, this is lower elevation. The predominant wind direction most of the time is in this direction. So if I have to locate my office, and I don't want to get the bad odor all the time, I'm going to put my office in the upwind direction. Are you understanding that it will help you avoid odor? And your groundwater flow direction is like this. Now let us see how we arrive at the landfill plan, landfill operation sequence, and how do we construct that. So as I said, if the road is here, you would prefer the weighbridge and the entry gate to be here, closest to the road. Of course, if there is some other consideration, that the weighbridge has to be here, then you'll have to make a road either internally or externally. Externally, this land may not be available to you. So then you might have to come in here and go along the boundary and come to this point if for some reason you want to put the weighbridge here. But normally you take the entry from the side which is closest to the road. As I said, the buildings and offices you might want to put here because the wind direction was in that side. And all leachate and surface water drains are going to run like that under gravity. So your collection systems will be here, right? Collection systems will be here. So between what I've already taught you, that 80% or more is the landfill area. So the shape of the landfill has now emerged like this. Agreed? And this shape is primarily governed by the outline and where I'm going to put the facilities. So entry and weighbridge, office buildings, laboratories, treatment facilities. And since the groundwater flow direction is in this way, I'm putting an upstream monitoring well and 3 downstream monitoring wells here. Any questions so far about what we have decided in the design? No. Great. Now, the other major thing is, the other major picture which should come into your head is this. That means that's your landfill. There will be a road. So there's a road, so there's a fencing all around. So first let us say that the dotted line, which is the boundary, becomes your fence. Normally you don't have a wall, you have a fence. Then there will be a peripheral road. You should be able to access any part of your landfill at any time on the peripheral road. You have a fire here, your fire tender has to go here, you have some injury or accident, you should be able to go. Then you are collecting leachate, and the leachate has to go to a leachate treatment facility here. Now, there will be pumps and sumps inside the landfill that will emerge, but there has to be a leachate header pipe, a big pipe in which all the leachate is coming. And whatever leachate comes out here, for example, it may travel like this. Whatever leachate comes out here, it may travel like this. So the red line is the leachate header pipe or the leachate main pipe, and it goes to a leachate treatment plant or a leachate storage tank. Similarly, you need a surface water drain. That means what falls on your cover is not going to be leachate. You don't want to treat it, so you should collect it separately. The problem is that your leachate and the surface water, if they mix, then the quantity of leachate becomes very large. So there will be similar to a road, there will be a surface water drain all around the landfill, and it will go to a surface water holding area. And also shown is a green pipe here. It should be all around, and that's the gas main. It should be all around. I've just shown it in small bits and pieces. All the gas which is pumped out, it can go to a flaring unit, and therefore this is what the leachate gas and surface water collection system looks like. Okay, next step. Now that you have got your outline of your landfill area, you have to decide your phases. The phases have to be decided in plan and have to be decided in section. Here is a landfill which is going to operate for 10 years. So 10 phases have been marked. First year you will fill this, second, third, fourth, fifth, sixth, seventh, eighth, ninth and 10th. And after that you won't be able to fill anymore. If it is above ground, if it is below ground, so if I have a landfill area, if it is above ground section, it will look like this. And if it is a combination of a below ground and above ground landfill, it will look like irrespective of that. If this is the first phase will be here, or the first phase will be here. I will be taking the phase to the top, because after every year you have to close. And then I'll move in the direction that we wanted. So here we had said our phases are like this. So 1 and 2. So that will be phase 1. And then there will be a phase behind that into phase 2. I'd like to now put my leachate collection wells. Okay. So where, let us say in phase 1, where will you put your leachate collection well? Is it at the center of the phase? Is it at the side of the phase? Why to the side? Why not to the center? We take all the leachate to the sides. We don't keep leachate at the center of a landfill. I will not be taking all my leachate here. I'll be taking all my leachate here. And if I have to start collecting the leachate from the first phase, suppose I make a well here, then this leachate has to travel all the way across. So typically, you will have a leachate well for one annual phase, typically. And I have said this earlier, that if you think that you can take leachate from one end to the other, suppose this is 400 meters long path and you have a 2% slope, then you have a 8 meters elevation difference between the two sides. So normally it is not done like that. You have an accordion arrangement and each phase may have its own low-lying area. So in now deciding that the leachate of phase 1 will not go somewhere far off and a well will be there in phase 1, where will you place it? Or a leachate collection point will be there, where will you place it? I can say, all right, this is my leachate floor, I'll make it like this. And I'll take the leachate to a edge. So it will be at an edge, but it can be any place, 1, 2, 3. So these are 3 locations one can think of, right? And water will have to flow, I mean leachate will have to flow. The middle one appears most appealing. Why? Because the amount of cut that you will have to do is less, because the distances the leachate will have to travel is low. So, and why do you keep everything to the side? Because if everything is coming out to the side, and if you are using a side slope riser, the height of the side slope riser or the height of the well, even if you are using a vertical well, is going to be less than if it is at the center. So take everything to the sides as far as possible. And the side slopes riser can rest on original ground, but even if you are doing a vertical well, the height will be less. So leachate comes to the side. So our thought process is that we can put the leachate wells, I'm only going to discuss 1 and 2, somewhere here and somewhere here, right? So let's look at what he says. So we have looked at 1, 2, 3 and 4. So what he has done, the designer has suggested 1 here, 2 here, 3 here, 4 here. So all the leachate will come here. Please remember, the leachate of 2 will go here, the leachate of 3 will go there, and the leachate of 4 will go there. So this will be kind of a ridge, the high point. Okay? There is often an attempt to economize on the number of wells. There is often an attempt to economize on the number of wells, and an alternate arrangement where you can reduce the number of wells is this. Here I put a well here. All the leachate from here will come here, and all the leachate from here will also come here. The distance to travel now is a little more. The distance to travel is more, but there's only 1 well instead of 2. So it's one phase is sloping like this, the other phase is sloping like this, and the well is at the center. So when phase 1 is being filled up, all the leachate tends to flow here. You have to put a small berm here so that the leachate does not cross over into the next area. When you start filling the second area, this is already filled. You can remove the berm and you can slope this way and collect it. So basically, this well is for 1 and 2. Similarly, for 3 and 4, this leachate can travel like this, and this leachate can travel like this. So this is the way you can economize on your wells. But they all go to the sides. The wells are mostly on the sides. This is not to say that there are no wells in the center. 7 is not touching any side, so maybe there will be a well somewhere in the middle. Then let's look at the gas wells. Where will the gas wells be? Are the gas wells to the side, or the gas wells are more towards the center? Why? So let it rise. It can rise on the side also. Density, though I don't know. The wells are at the center because you put the wells in the depth, maximum depth of waste. So if you put a well at the side, if you were to put a well here, I don't even need a well here. I don't like to put a well here, but this is the maximum height, so you tend to put the wells 2/3 of the depth of the waste where the waste is a maxima. So your wells will not, gas wells will be at spacing of 50 to 75 meters towards the center. So the starting phases which are on the sides may not have many wells. May not have many wells. You may have a gas collection perimeter trench. You will have the gas collection layer under the cover. They will work as gas collection. Wells may be used at slightly different locations. So just to get a feeling of what we've done, that's where the wells may be. See, the landfill height is increasing like this, then decreasing like that. This is the area where most of the wells are going to be. Okay, so you do see that 1 and 2 only have a single well, 3 also has, but the 4 and 7 will have many more wells at spacing of 50 to 75 meters. Of course, this all depends on the dimensions, but I just want you to get the clear picture that the leachate wells are towards the side and the gas wells are towards the center. Agreed? Now let us say I am in the 5th year. First year is over, I've capped it. Second year is over, I've capped it. Third year is over, I've capped it. And 4th year is over. This is being capped. 5th is where the waste is coming, and 6th is under preparation because next year the waste will come here, right? So now I have to manage everything. I have to manage the leachate which is coming out of 1, 2, 3, 4. It will have its own wells. I have to manage the surface water which falls on this. That means it has to run off into some drains. So there has to be a surface water drain. If all this water falls into the active phase, it will make more leachate. We don't want it to make that. And in any case, remember, this land has not been touched. This may be still scrub land. You don't go and clear up the own area. I don't have the money for doing that. I do each excavation every year at a time. Next year, while this is active, this is being prepared. Still, this is untouched. So what I want you to see is this. I have completed these, so the leachate will be going from these to the leachate main, and the gas will be going from here to the gas main, from here as well as from here into the gas main. And you may have laid the full leachate main to the facilities, or you want to save some costs. You say, no, I don't want to. So you may have only put part of the leachate main going to the facility directly, and you will relocate it as you go forward. Let's look at what happens to the road. There's a road which has to be made all around it. An owner who has got a lot of cash flow, ease in cash flow, can put a boundary fence and a boundary road all along. Well, suppose the site is 800 meters by 1500 meters. So you would have 4.6 kilometers, 800 into 1500, perimeter will be 4.6. You'll have 4.6 kilometers of road. If you have the money to invest in 4.6 kilometers, fine. What he will say is, I'll make a cycle track so that my guard can go every day, but I'll only make the road as this progresses forward. Or he'll make a kacha road or something like that. So these things have to move forward step by step so that the expenditure is deferred step by step. So here in this diagram it is shown that the mains have already been put, and your road may go like this, and your trucks have to come and deposit the waste, so it may come here, and there will be a road here, and there may be a road here. So in the trucks will come and deposit it in the active. The road required here is to prepare this, and then they all might meet up and go back. So the whole thing may not be developed. Okay? Also remember that the surface water drain, very important, very, very, very important. What is falling on this must go into the surface water drain, right? And the surface water drain is also at the cover at the top. That means no rainwater falling here should go into the under preparation area or should go into the active area. Remember, this is higher. It has to be sloped backwards, but still you need an interceptor drain here so that in case of a lot of rain, water collects into this and then runs off down. I only want the rain falling on this area to be creating the leachate. Whatever falls on this is also surface water. Whatever falls on this is also surface water, surface water, surface water, surface water. So you have to collect it in this drain and bring it to the surface runoff. Don't allow this to mix with this. There will have to be a berm here. Leachate will be formed here. We talked about a well. I think we had said 1 and 2 will have a well here, 3 and 4 will have a well here, 5 and 6 will have a well here, right? So the well will be installed and the leachate will be coming here, but there will be a berm. Whatever falls into this area will become a surface water, and it will go into the surface water drain. And whatever falls onto this area will also become surface water, and will go into the surface water drain. So in this way, we will gradually progress year by year. So if you do incremental development, your expenditure is incremental year by year, your income is incremental. That means your cash flow is better, because if there is a waste tipping fee, then as you put the waste, you are getting income also. That income can be put into this. If you get say, no, I'll develop the whole thing, sure, you can. But 2-3 things here. You'll have to make a lot more investment. When you make a lot more investment, then if you don't have money, you will have borrowed it from a bank. You'll have to pay the interest back to the bank. So if you're paying interest on a lot more investment, what did you do? Because income is not coming for the income will come only from the waste which is coming daily. If you had done half the investment, then this income could have offset the interest and also given you an operator's profit. So do not do too much capital investment to begin with. Do the work incrementally forward. But minimum things, you have to put a fencing, you have to have a peripheral reach so that you can go and check that everything is working, and you will have some of your treatment facilities at that end. You should be able to reach that. Any questions? Okay. Then if I look at this, and if suppose this is going to be my completed landform, it's a below ground and above ground, or primarily below ground landfill. Remember, again, I'm going to say this. This is the phase which is closed. The brown is the cover has been placed. Whatever falls on this goes as surface runoff. So the blue line is surface runoff. It goes to the surface runoff drain. Whatever is coming out from inside the waste, which is either squeezed or some partial inflow, will go to the leachate main. The active one will create the maximum leachate, because when the rain will fall over this, it will create. On the top, you need a berm here so that this water doesn't come, and you need a little surface drain here also so that the water doesn't come in any case. This I have seen in so many sites, that in a very heavy downpour, there is a tendency for erosion gullies to be formed and water to start falling into the active area. This has to be very carefully planned, so that the surface water remains surface water. Even when you have dug this up, this is being prepared, this is active. Again the tendency is कि पानी सारा इसमें चला जाएगा. यहाँ well आपका यहाँ है ना, is the low lying point. Unless you put a berm and unless you pick a system here and a pump and pipe to take away the surface water, it's going to get mixed with this. That's not a great thing to do. Today, if I just talk to the Ankleshwar landfill people, the rate of treating a liter of water, I think it's ₹4 or something for them. So it's an expensive thing to do, to treat so much leachate once it is generated. So keep it out, have the slope this way, the surface runoff, have the slope this way, the surface runoff. Only here you will get leachate. This leachate, because it is closed, will be much lesser than this leachate because this is active. Agreed? What does it look like when the whole landfill is finished? Now everything is fully developed, right? You have your entrance and weighbridge, you have your fencing, you have your road, you have your buildings, the office, the laboratory, the waste inspection facility, the garage, the equipment, everything here. This is the top of the landfill. At the top there will be a road, and there will be a surface water drain, so that whatever falls on this goes into the blue surface water drain. This surface water drain is connected to this drain, and then this is connected to the lower drain. So remember, that's your base surface water drain, and whatever comes into this drain goes into a surface water collection tank. If a lot of muddy water is coming out, you can allow the mud to settle. Whatever falls on the top surface goes to this drain, comes to this drain, and then eventually comes down. And this is a berm, an intermediate berm, right? There's a surface water drain and a road on the berm. And whatever falls on this slope is collected in this and then comes down here. Whatever falls on this slope comes to this drain. And your road is here. You can travel up this road and come to the first level berm. And you can travel up this road. The berm is at a particular level. Then you can travel up this and come to the top. So you have access for everything. And remember, this is dotted with gas wells, and there is vegetation, and this is the entire area, how it has developed. I would like to now focus on this small area between the fence and the base of the landfill. So once you have said that this is my boundary, and this is my landfill, what is critical in this area? What is critical in this area? Any doubts? Anybody? You have an issue? I hope it's visible from that far. So if I have a fence, then normally there will be requirement of a green belt. You don't want to see the landfill. So if you have a 15-meter high landfill, you would like to have tall trees. So there will be a green belt, minimum offset distance prescribed in the rules. So you can have the visual impact reduced. You think there are a lot of trees, but behind the tree is the mound. So there's a green belt, and then there's a road, right? And then there are those three pipes that we are talking about. Those are the three pipes: the surface water drain, the leachate main, and the gas main. That's your fence. That's your green belt. Typically, it may be 10 meters wide. You may have a road after that. You have to basically decide how wide the road is, whether one vehicle is going around and coming back, or there are two vehicles going in both the directions. So it will all depend whether two trucks have to pass each other. One tends to keep the road one vehicle and have certain bays in which these vehicles can pass, because making a double width vehicle road is more expensive. So one tries to keep, so there's a road. And here you can see is the surface water drain and the leachate header pipe. Here also the gas header pipe is shown underground. But the important thing is, you must be clear that the surface water which runs down this will go into this drain, and the leachate which comes out will go into the leachate collection pipe. So here what they have done is kept a pipe. If both are open drains, then they would have to cross each other for the surface water to go from one drain to the other. Either way, suppose both are open, leachate drain is also open and surface water drain. So when one is carried to the other side, it would have to cross over, which is difficult. But when you have a buried pipe, there is no issues. You can put the geomembrane on top of this and the surface water will reach here. So in this way, this criticality is very, very important. And you maintain this. The good thing about open drains is they can be maintained. The good thing about pipes is they are closed, non-maintainable, unless you send in some pipe cleaning devices. But if you keep the leachate pipe open, there's an issue about odor and smell. So it's better to keep the leachate in a closed pipe and the gas in a closed pipe. So that is the way you finish off your landfill. So we've done this today. This is a quick wrap up of what we've done so far. That how do we evolve the plan? How do we evolve the section? In the plan, where do we place the buildings and where do we place the various infrastructure facilities? And how do we do the phases? In the phases, where do we put the wells? In the phases, where do we put the wells and where do you put your leachate wells and where do you put your gas wells? How do you manage the landfill when you are at an intermediate stage. So if you go to a well-designed landfill, this is what you will see. Green vegetation on the closed part. The intermediate cover will have soil on it, and if you are conscious about it that monsoons should not affect it, some people will also have a temporary tarpaulin or a temporary cover on the intermediate cover. And you will see the landfill rising up in the active phase, and you will find some machinery is working in another phase which is under development. There the excavation is taking place, the clay liner is being laid, on top of that the geomembrane is being laid. And all the area after that is still the original scrubland or the original shrubbery and the trees. And in that you have your surface water drainage systems. You don't want any water to come into the landfill. So that's typically a good design. But I've seen many landfills in which they've already laid the liner for 5 years. Why? Because they got some funding from the government. So it was a block funding. Under JNNURM, I have seen people make 5-year phases, do the liners and everything ready. Only a little bit of landfill is being used. And in the other portions, you are getting the sand is clogging up because there's a leachate collection layer, erosion on the side, somewhere something is getting exposed for because you put something for 5 years on a slope and you don't do stone pitching on it. Slopes are going to be very prone to erosion all the time, as we know it. So that sometimes causes trouble. So as you move forward, you have to repair those things and then use the landfills. Any questions? Okay, we'll stop here. Thank you.